So let's kick off here. Again, this is authoring and deploying serverless applications with AWS SAM. And again, my name's Chris Munns. I'm currently a senior/lead developer advocate for serverless at AWS. I'm actually part of the Lambda and API Gateway product teams, and that includes serverless app repo, SAM, and kind of our general ecosystem around serverless applications. Came down from New York for this here today, and I've been at AWS for just a little over 6 years across a couple different roles. But previously, before all of my time at AWS, I came from a fairly traditional, what I would say is a operations/sysadmin/ what we'd call DevOps or maybe an SRE type of background. And what I find so fascinating about the serverless space over the last couple of years is it basically takes everything that I did in my career before serverless and to a pretty large degree throws it out the window. So I've spent time in data centers doing rack and stack and managing servers and clusters of servers and all of that. And hopefully, if you've been here the last 2 days, you've seen quite a lot of stuff about serverless and about Lambda, and probably got an idea of just how drastically it changes things. So why are we here today? So it's really interesting. Out in the hallway, there's a board about the top topics that we've seen so far this week at the Worldwide Public Sector Summit. And right now, Lambda is #1 by a very, very, very large majority. And so we first launched Lambda back in November of 2014, AWS reInvent. It went GA in April of 2015. And what we've seen in the last about just 3 years or so has been a really, really huge growth in customers looking at serverless, being interested in serverless, customers that are going from on-prem to cloud and starting with serverless. We're seeing a lot of customers that are completely bypassing the container space and going right into serverless. And so here in today's talk, we're going to be talking about SAM, which is part of our ecosystem, one of the kind of core tools that we have here at AWS. And I find it to be actually a really awesome tool in working in this space. So real quick here, typically I wish I had done this talk earlier yesterday, so you would probably already have been past this. But just for those of you who haven't been to any serverless talks yet this week, in terms of serverless at AWS, we have a pretty firm definition. I like to say that we have a pretty firm box that we paint our serverless products into, and the things that don't meet this criteria, we don't consider serverless. So for us, serverless, again, it comes down to 4 things. No servers to provision or manage. This means no physical, virtual, or even containers that you would manage as a customer of a serverless platform. It should scale with usage. So as requests come in, we're going to take those requests, handle them, return back whatever the response, or do whatever the work is based on your business logic. Never pay for idle. So there's lots of industry stats out there that talk about how much of an organization's resources are sitting idle the majority of the time. It's well more than 50% by most of the metrics out there. And so what it means is effectively 50% of the money that you've spent on those resources never returns any value to you as an organization. And so with the serverless products, you never have to think about turning that knob for capacity such that you'd have idle resources sitting around being unused. And then lastly, availability and fault tolerance built in. So here at AWS, we have a concept of regions. Inside of those regions, there are availability zones. And one of the most core, basic foundational concepts of availability in AWS is this concept of multi-AZ. And so with the serverless products, you should never have to think about architecting for this. It's going to be inherent in the products that we have. So in the center of this world is AWS Lambda. Again, AWS Lambda is a compute service. And the way that Lambda works is you have your code. Today we have 5 primary languages that we support. I would say that there's a very rich ecosystem of open source tools that allow you to run almost anything inside of that today. So you write your code, you upload it to the Lambda service, you configure an event source. There's about 30 or so plus services today that can invoke Lambda functions from AWS. It also has an API that you can use to plug into your application code wherever you want. And when an event comes in, it causes a Lambda function to be triggered. So what this means, behind the scenes in the Lambda team, we run a massive, massive, massive amount of compute capacity in each of the regions that we're in. We will go and essentially take one of those compute resources, align it to your account, pull down your code, bootstrap that code's environment, pull in the event request. Your business logic is executed, and maybe it talks to databases or data stores or other APIs, what have you, and then essentially returns back the result or acknowledgement or does whatever it needs to do. And now we bill you only in the hundreds of milliseconds. And so it's a very, very, very different way of thinking about how you build applications and how you deal with infrastructure in the hundreds of milliseconds of time. Very small, very focused business logic-based bits of code. And so in terms of the anatomy of a Lambda function, there's just kind of a couple of core concepts that matter to you. The first and most important one, I think, is the handler. The handler is basically your entry point into a Lambda function. It is basically where your logic of your code starts. And now that can obviously go out to other functions or talk to other libraries or other things inside of that. But this is basically the entry point that Lambda is going to point its event into. Then you have the event object. So the event object is the actual data coming in from your event source. In the case of an API, this is going to be the information passed in from, say, an API gateway. In the case of, say, something like S3 that invokes Lambda, that's going to be information about the object and the API activity that initiated that request. And so typically, you're going to pull in the event object, process what's inside of it, or gather some information in order to derive what it is that your code is going to do. And then there's the context object. And this basically allows you to interface with kind of the rest of the environment and some of the underlying configuration of your Lambda function and pass back success and stuff like that at the end of your function's execution. So again, kind of 3 core concepts here about a Lambda function for those of you who aren't familiar with it. So a couple other things here about Lambda. Again, you bring your own code. This is a fairly open compute product. You write your code however you want to write your code. If you want to include libraries, whether they be open source or private, you can. Again, you can use one of the various supported languages that we have here, or one of the third-party frameworks that you could find. In terms of the resource model, there's basically one knob that you turn with Lambda. It's the amount of memory that your function has. And today, we support anywhere from 128 megabytes to 3 gigabytes. And what comes with that is a proportional amount of CPU and networking capability. So when you go from 120 megabytes to 256, you effectively double the CPU capability that you have compared to 128. And now at 1.8 gigabytes, we go from giving you 1 core of CPU capability up to 2. So then you start having 2 cores that you have access to. So you can actually do parallel processing inside of a Lambda function across multiple cores above 1.8 gigabytes. Flexible to use, so synchronous or asynchronous. We'll talk about this here a little bit more in a moment. And then because it's AWS, so we consider security to be our top priority. That does not change anything with Lambda here. Security is very deeply integrated into Lambda. We'll talk about some of the concepts here as well. And actually, here we are. So in terms of the permissions model, there's kind of 2 core concepts for Lambda. And what I'll boil it down to is kind of 2 things. There's, what can my function do? Can my function talk to a DynamoDB table? Can it access data in an S3 bucket? Can it call, say, an API inside of my account? And then there's, who can invoke my Lambda function? So am I going to allow a Kinesis stream to invoke my Lambda function? Am I going to allow an SNS topic to invoke my Lambda function? And so basically what that does is give you kind of 2 core aspects of the security model for Lambda. And both of these policies here, execution and function policies, are things that you must configure for Lambda functions. And more recently, we actually got support inside of the AWS config service, which allows you to actually now to do kind of full governance and auditability of these policies. We actually have a couple of managed config rules in there that can say things like, hey, guess what? Your execution policy is too permissive. And so for organizations that want to have kind of very fine-grained constraints around these, you can actually now police them with config rules, which I think is pretty cool. So in terms of the execution model, there's 3 main ways of doing this today. Synchronous push. So in this case, we have, for example, an API gateway. We have a call to our order API that's going to directly invoke a Lambda function, and then we're expecting that Lambda function to return a result up to us. We have asynchronous. So take, for example, Amazon SNS, simple notification service, or Amazon S3, simple storage service, where we have, say, a message put into a topic with SNS, or we've had an object uploaded to an S3 bucket. Those services will then go and invoke the Lambda function, but we're not expecting Lambda to return a result up to them to talk to the client. And you can think of use cases, for example, let's say that you take a data file, maybe a report from folks out in the field, a report from the agency that you're working with. That file goes into S3, you pull into Lambda, you do some data processing on it, and it goes back into a data warehouse somewhere. It's not the kind of thing you're going to expect a response back upstream. And then lastly, we have stream-based. So today, inside of Amazon DynamoDB and Kinesis, what we have for both of those services is that we can stream activities or stream records that are put into them into Lambda. In this case, the Lambda service pulls those, looking for activity, pulls down the records, and can act upon them. And now, real soon, we pre-announced this back in April, I guess, we'll have support for SQS to be directly connected to Lambda. And this is coming really soon. It's going to be really awesome. So now you can have SQS directly invoke Lambda, do kind of massive parallel processing of messages off of a queue. And so that's going to be, again, coming here real soon. So some other bits here about Lambda. So in terms of authoring functions, you can continue to use the same development tools you've always used. We've got plugins for Visual Studio Code. We've got plugins for Eclipse. There's community plugins for all sorts of other IDEs out there. We have our own IDE, Cloud9, which I'll be demoing here a little bit. In terms of monitoring and logging, this is another kind of core concept with Lambda that's built in. So all you have to do is output messages inside of your Lambda function, effectively a console.log statement. We're going to capture that and put that into CloudTrail logs for you. And then also, into CloudWatch logs. And then in terms of metrics, there's a number of metrics that we capture by default, but you could very easily in your code create new ones using the CloudWatch APIs. In terms of programming models, so this is at the end of the day, behind the scenes, this is a true server running in the cloud that you don't have to think about. So you have access to processes, threads, there's temp storage space, you can use networking sockets. So again, the way that you've been developing applications doesn't have to change that drastically. And then lastly, these are stateless. So I talked about how we will take your request, we'll put it on side of a compute resource, we spin up an execution environment for you. What we can't give you is any sort of affinity of that compute resource. So you can't do, for example, things like sticky sessions. And while you do have access to stuff like temp space, we kind of periodically will go through and potentially have to pull back or delete the underlying instance that the Lambda function is executed upon. And so you want to be really, really careful about trying to persist any sort of data into a Lambda function. Kind of pushes upon you best practices of using a real true data store, whether it be an in-memory cache or a true relational database or a NoSQL database or say S3 to store your data. And so because of this statelessness, it does change a little bit around the model of how you think about developing for Lambda. So going back to event sources, again, we've got 3 different models today. Across this, there's 30 or so different products that can directly interface with Lambda. We've got various data stores. We've got endpoints. So how many of you have an Alexa-capable device at home? A lot of you. Awesome. So there's a very good chance when you ask our good friend Alexa to do something, she's actually executing it via Alexa skill that is powered by Lambda. And actually, it's a really great way to get started with doing Alexa skills via Lambda at basically no cost. Development and management tools, and then event message services. And actually, the one there on the far bottom corner is one of my favorite. You can actually have scheduled Lambda functions that act like a cron. And so in my years as a sysadmin, I spent way too much time trying to do highly available cron servers and dealing with failover and tracking and locking and all of that. And now you can do it completely serverlessly without having to think about some of that stuff. So in terms of common Lambda use cases, it really kind of today spans almost anything you'd want to do. We've got customers that are replacing, say, traditional multi-tier Java enterprise-like applications with, say, single-page app web apps, so things like React and Vue and some of the other JavaScript languages on the front end. And then they've got APIs on the back end powered by serverless. And so you can basically get rid of ever having to have any server power any part of your application with this. Backends for mobile and IoT. Data processing, so the ability to, say, pull in something like Kinesis to have it act on data in near real time. That's actually one of the biggest use cases for Lambda by volume today. Some customers doing many, many millions of invocations per day of real-time streaming processing with Lambda. Chatbots, so we're finding chatbots popping up all over the place. We see companies using chatbots both externally and internally. Chatbots, for example, for things like internal HR tools, internal facilities tools. There's all sorts of things that you can do to replace, say, a ticketing system or putting somebody on the phone with someone via chatbots. Alexa, which I already talked about, and then IT automation, which is probably where a lot of you will start to dip your toes. But there's a lot of cool stuff here, and actually Capital One released a tool called Cloud Custodian, which uses Lambda behind the scenes as part of its policy engine. And so there's a lot of things that you can do from a management tool space, from a compliance, from an auditability, from governance, by plugging Lambda into things. For example, CloudTrail, Config, a number of the other services that we have. So that's kind of big picture with Lambda here. Let's get more into kind of the meat of what we're here to talk about. And so we'll talk a little bit here about my good friend Sam. So as we see here, we've got this wonderful little squirrel mascot. You'll see Sam pop up all over the place. This is the official mascot for serverless here at AWS. The backstory is a little bit of a mystery, and so sometimes you'll hear us come up with different reasons. Don't worry about the backstory, just enjoy the cute little squirrel friend, and again, you'll see it in all sorts of places for us. But now SAM is actually a real thing, so it stands for Serverless Application Models. It is a tool that you can use to build and deploy serverless applications. So this is currently today you consider it an extension built on top of CloudFormation, so it uses CloudFormation behind the scenes, but with some special resources, which we'll talk about here in a moment. And so because it's built on top of CloudFormation, it supports essentially almost anything that CloudFormation can support. And this is actually an open source specification. We actually recently just open sourced the actual translator, which takes the SAM code and translates it into CloudFormation. And we're really excited about some of the community-driven pull requests that we've gotten in looking at trying to expand SAM. So again, SAM's built on top of CloudFormation. CloudFormation is a service that's been here at AWS for, I think, almost 8 years now. It's a template-driven product where you write a template to define the resources for your application or for inside of your AWS account. And then you throw that into the CloudFormation service, and it's going to do smart things like building out resources in the right order, such as if you have dependencies, it'll do automatic resolution of that. And so you can use it to kind of track your infrastructure as code via kind of the entire life cycle of that infrastructure and application. So it fits really well into CI and CD workflows, and today we support both JSON and YAML. Now, if we were going to launch a serverless application with CloudFormation, it would look a little something like this here. And now I'm not going to expect anyone to be able to read this. It's a lot of text in a very small window. This is not desirable when it comes to building and launching serverless applications. This is a whole lot of work. So 80 lines of, in this case, YAML, which is a considerable amount of YAML. Now, if we were to take this exact same amount of CloudFormation and write it in SAM, it looks like this. So this is just about 20 so lines of code. Again, also YAML, but this is an example of a SAM template. And so there's a couple things that are going on inside of the SAM template. At the very top, we have our headers, and the second line is the most important one that we have here. It's a transform. So CloudFormation has a concept of transforms. These are basically special capabilities in CloudFormation that when it sees a transform header, it says, OK, this is not a normal template. This is a template that I have to transform or expand into another way. Then what we have are two different resources inside this template. The first one is a serverless function. And we see some properties related to Lambda, the code URI, the handler, the runtime, the policy. Then down below that, though, we have an event. And we see that has an event name, has an event type of API. And then we see some properties that are related to an API-based event. And so what this top part here is going to do is build out a Lambda function, build out an API gateway, give the policy such that the API gateway can invoke the Lambda function, and then give my Lambda function access for it to talk to, or give it a policy called Amazon DynamoDB read-only access. At the very bottom here, we have another resource called Simple Table. And much like the name suggests, this is actually a very basic DynamoDB table that'll be configured for you with a base read and write units of 5 each. And so this very simple template, again, is going to give you a Lambda function, an API gateway, a DynamoDB table, all the permissions to glue all of this together, and again, saving you from writing about another 70 or so lines of code. Another way to think about this is we have an example that I'm going to show here in a little bit from an example in GitHub that's called SamDance, and we'll see this here in a little bit. And there's roughly about, I think it's 16 or 17 lines of code that expands out to 7 resources inside of AWS. And so this little diagram over here is actually taken from the CloudFormation designer. And so you can see the resources, their relation, and what it is that exists. And again, it's just from those about 16 or so lines of code. So again, really, really simplifying your life. So let's talk a little bit more here about what you can do with SAM. So again, today we have 3 special resources that are part of SAM: function, API, and simple table. And while you don't have to write out all of the things that are here, we pretty much expose to you almost all the capabilities and configuration properties of the underlying resources. But again, what SAM does is it attempts to basically use kind of very sane defaults and pre-create these resources without you having to define all of them. If you were to do this in raw CloudFormation, there's a lot of these that you would have to define, for example. So you see here a function, and we have access to things like memory size and timeout, event structure, tracing, tags, kind of all the stuff we'd really care about if we were launching a Lambda function. In terms of API, we've also got a number of things that we can do here. So we've got, for example, the ability to reference a Swagger template. Swagger is another templating engine for building, deploying, and managing APIs, very common in the API world. We could turn on things like caching inside of our API gateway. We could send set our endpoint configuration. There's actually a bunch more that we can do here inside of the API definition these days. And then lastly, simple table. And again, this is a DynamoDB table, some of the basic properties here. But again, you don't have to define all of these. So pretty straightforward syntax, again, very minimized from what if you were doing this in raw CloudFormation. Let's talk a little bit here about the event source types. So again, we have about 30 or so events or services at AWS that can directly invoke Lambda. We don't have support for all of those inside of SAM today, but we hit the biggest categories of them. And actually, a number of the services that support Lambda today do it through Amazon SNS. So that's kind of a gateway to a bunch of other capabilities. They all kind of follow the same structure. So you'd specify them as an event, they get a name, there's a type, and then there's properties. So all these are going to loosely look the same in terms of syntax. So for example here for S3, we see that we can define a bucket, we can define the events that we care about, so puts, gets, and deletes. And then we have the ability to specify rules. So name, and then you could say either the prefix or the suffix. So inside of S3, you typically are naming your objects related to some sort of key space, or you can think of it as maybe like a foldering strategy inside of S3. And so this allows you to, via the prefix, define kind of a folder space inside of S3 that you care about. In terms of the suffix, maybe we only care about certain file types. Maybe we care about .docx or .pdf files, and we don't care about anything else inside our S3 bucket for this given Lambda function. And so we can specify that here in terms of the rules. SNS, pretty straightforward. We define the topic that we're going to be listening to, that we're going to allow our Lambda function to be invoked by. Kinesis and DynamoDB, also very similar to each other. We specify the stream arn, and then we've got the starting position and the batch size, which we can configure. Skipping over API, because we've already seen that. Schedule, so again, this is the cron job that you can do with Lambda. And so you can actually have a SAM template, defines your Lambda function, defines your cron schedule, and it's the same syntax that you would use for cron if you've ever set up cron on a Linux or Unix-based system. And so it makes it really, really easy to do that. But we also support something called rate expressions down here. So you see a rate of 10 minutes or a rate of 1 hour, and that's going to translate up to kind of the standard cron syntax that you've known to use for years. And then lastly here, again, just going to jump over some of these, is Alexa skill. And so this is the easiest of all. You just say type Alexa skill, and this is going to allow your Lambda function to be invoked by Alexa. The rest of these here, CloudWatch events, IoT rules, also pretty similar to API and to S3. Certain rules you can set, but otherwise really, really straightforward syntax to glue these things together. Now we also have a development tool that we launched last summer that recently also got overhauled a bit. Previously it was called SAM Local, now it's just called SAM CLI. And so what SAM CLI allows you to do is actually build, validate, and test a serverless application local in your environment. So you can start at nothing, both say on your workstation or your laptop, or inside of Cloud9 or any other environment that you have. You can use a command called SAM init, and it will create an entire environment for you to get started in. But one of the coolest things about it, and why we used to call it SAM Local, is that one of the other key aspects about this is it actually will allow you to take your serverless application, bundle it up inside of a Docker container, and run that Docker container locally as if it was mocking the Lambda environment for you. And so we could do this with both a kind of a fake API gateway entry point into your Lambda function. We also have the ability for you to pass invocations directly to it via passing or basically piping in a JSON structure, just like it would get from the other event sources that exist. And so this allows you to do really, really in-depth local dev tests directly on your laptops without always having to be able to commit up to the live services themselves. So with SAM Local, again, or SAM CLI, I should say, pretty straightforward. It's got a couple of base commands. So it has, again, init, that allows you to create a new application from scratch. Package and deploy are the two key commands for SAM that talk to CloudFormation and allow you to deploy your application. The first one, package, actually takes your application, zips it up, puts your artifact in S3, and updates your SAM template with the location of it. And then deploy actually executes a CloudFormation change set create, and then change set execute in order to create your environment inside of CloudFormation. Now, local and validate are probably the two key ones that you'll use as part of an active developer. So validate, much like it sounds, allows you to validate a SAM template. Is this the correct format? Do I have the correct values? It's actually really smart about making sure your SAM template is right. And then again, local is what's going to take your environment, throw it into a Docker container, start up that image, run it locally for you, or give you the ability to directly pipe events into it. And so let me show you this here running. So I'm going to switch over to my laptop. Second. Demo God's always with you when you need to log into your laptop while on stage in front of a couple hundred people. There we go. Cool. So I'm going to show you inside of Cloud9 here how this all looks. So Cloud9, again, is an IDE that AWS a company actually we acquired, and then we relaunched as an AWS product back at reInvent this past year. It's a really, really powerful IDE. I've been doing all of my development inside of it now because it's got a number of kind of really awesome things built into it. Like any other IDE, we can see here I've got my text editor. It does things like completion, does validation on the fly, like syntax checking, a lot of good stuff here. But what's really cool is kind of the integration that it has with the rest of the AWS environment. So I can actually go over here to AWS resources, and I can actually do things like pull in other Lambda functions that I have configured right now. And it will pull down the complete artifact, put it into its local environment, and allow me to play with that code. And so that's actually what I've done here. So I have an environment running for an application called SamDance. And so SamDance is this demo that we have. And what it does is it draws a SAM on your screen. And it talks back to an API that tells it how many SAMs it should show on the screen. And then they kind of bounce off of each other and move around here. And so the API is really straightforward. All it does is return an integer that tells it how many SAMs you should draw. One interesting thing to note about when you have this number as high as I do, and I believe this is at 255, as you can see, they just kind of like wiggle on top of each other. It also is a really good way to stress out your computer and make it really hot. So in the cold months, if you want to warm up your lap, you fire up SAM demo for your laptop. It's great. I'm going to close this before my laptop bursts into flames. So I've pulled down the code for this, and actually you can find this code up in GitHub in AWS samples /AWS-serverless-SAM farm. It's all out there. So I've pulled in this environment live from Lambda. And what I've got here right now is the SAM count is set to 5. What there is there's a multiplier. So right now the multiplier is set to an environment variable or to 1. And then it's really straightforward. It basically goes, and at some point it returns the count that I have, as well as some headers for this to go pass back through API gateway. So really straightforward function. I've got a SAM template in here that's also pretty straightforward. It's got some parameters that are going to get passed in. And then it's got my resource, which is just this single resource, which is called getSamPartyCount. So we can see this is a serverless function. It's got some very basic aspects about the function itself, where the handler is, the version of Node.js, where the code URI would live, which gets replaced during SAM deploy. I've got X-ray turned on, tracing active. I've got my environment variables. And then down below here, I have my actual API event definition. And so I can go and play and hack around on this, and then I can come over here to AWS resources and go up to the top here, where it shows my local function. And I can say run local. And so what this is going to do is actually, again, take my Lambda function, throw it into a Docker container, and pass in the invocation request for this Lambda function. And so we see here, let's see if I can make this a little bigger. Oh, that's too big. Somewhere in the middle. We've got back here my count of 5, right? So really straightforward. Now let's say I was going in here, and I was as bad of a developer as I am, and for some reason I set SAM count to cats. That is not a valid integer the way that most people think about integers. And so in this case, I actually get an error, as we'd expect. It comes back and tells me where the error is. So I can come back and say, oh, I accidentally set this to cats. Let's send this to 20. Come back, run it, and I get my updated value here. And so again, I could really quickly iterate on this Lambda function, do testing of it, be able to continue to iterate on my product, all without having to leave my IDE, all without having to push it up to the live service and test it. And I'm showing you now here SAM CLI installed as part of Cloud9, but I could just be doing this directly inside of my terminal window all the same. I don't have to use Cloud9 as part of this, but you should, because it's cool. I'm going to go back to slides now, please.
Quick question. So on Cloud9, you're not running SAM local, but it's running already in AWS?
So the question was, in Cloud9, is SAM local running? So SAM local, or SAM CLI, is installed in Cloud9, and through the interface, it's executing the CLI commands. It is.
And to run that test with the squirrels, did you deploy?
Sorry, so the squirrels moving around was in the live environment. Yeah. Okay. So that was, again, really quick environment here. Again, inside of Cloud9, really easy to get started with this and dive in and start playing One thing that I didn't show was the SAM init command. So you can actually just fire up again a Cloud9 environment, go into the terminal window. So Cloud9 runs on an EC2 instance, so it gives you shell access. Do SAM init, or you could go through the GUI and create a Lambda function. And so I find this is probably the easiest way to get started with playing and exploring and learning Lambda, is because there's basically nothing you have to install, nothing you have to think about. You can just dive right into it. Cool, so let's talk a little bit more here about SAM and about some of the capabilities. So again, this is a CloudFormation template. It actually has nothing to do with serverless. But what I want you to get from this is that there are some common core capabilities of CloudFormation that apply still to SAM templates. Headers, parameters, mappings, conditionals, resources, and outputs. And so we've already talked a little bit here about the headers and the resources, but some of the rest of these sections are just as valuable to you. So parameters are what allows you basically at execution time to pass in data to your CloudFormation template. This can be for all sorts of use cases of user-fed information to the template. Mappings are essentially predefined conditional case statements, and we'll talk a little bit more about this here. Conditionals allow you to basically take a look at a parameter that's passed in and decide whether or not you should do something inside of your template. So let's say that I had a parameter that was called environment, and based on the environment being set to dev, I want to do one thing, and being set to prod, I want to do something else. Conditionals allow you to do that. And then outputs are the actual results of my CloudFormation stack. So if my CloudFormation stack is going to create a Lambda function, an API gateway endpoint, a DynamoDB table, I can go and look at the outputs and find the resources that were created. I can also take those outputs and do what's called exporting them. And when you do an export, that allows you to then import those resources into another CloudFormation template without having to, say, pass it as a parameter. So this allows you to do all sorts of interesting cross-stack resource sharing, much simpler than with having to pass it directly via a parameter. So again, because SAM is built on top of CloudFormation, it supports pretty much anything that you could do in CloudFormation. So even though we only have 3 special resource types, it doesn't mean that you can't create inside of a SAM template, say, a Kinesis stream, or define a VPC, or create IAM resources, or an RDS database, or if you still care about servers, create an EC2 instance, for example. All those capabilities are supported in there. It's just that transform header and then the special resources that make a SAM template unique. Again, it supports the capabilities I just had before, parameters, mappings, outputs, et cetera. It supports what are called intrinsic functions. This is kind of a core capability of CloudFormation. Again, import, export, and you can write your SAM templates in either YAML or JSON, depending on what it is that you like to use. So let's talk a little bit about some of how you can put all this together to do some cool stuff. So inside of Lambda, we have environment variables. You can think of these as key value pairs that you could pass into your functions that, again, allow you to pass in all sorts of data, whether it be, say, feature flags or configuration information, or even things like secrets data, although we do prefer that you use something like parameter store or secrets manager to do that today. So we could take these environment variables, and you actually saw that inside of my SAM dance Lambda function, it was taking in an environment variable for a multiplier on how many SAMs I should have. But really, really powerful part of Lambda. We also have something called API gateway stage variables, very similar to Lambda environment variables. In this case, it's, again, a key value pair that you could pass in. And then these stage variables are made available downstream to the backend for your API functions, as well as to API gateway to allow it to do some dynamicness. And so what we could do is we can combine these two things inside of our template via, say, parameters or mappings, and be able to make our templates very dynamic. So we see here that I have a parameter called myEnvironment. It has certain values that are allowed, testing, staging, and prod. I then down below have a mapping, and the mapping correlates actually with the various environments. And then based on that, I have some sort of attribute called status. And maybe you could think of this as a feature flag for my application. And so inside of my Lambda function then, I'm going to pass into the environment variables the environment for my function. So I'm refing there. That's an intrinsic function, that exclamation ref. I'm refing the parameter. And then I also have down under special feature 1 here, another intrinsic function called find and map. And what this is going to do is it's going to say inside of the special feature 1 mapping, pass in my environment and pull out status. And so based on if I was doing this in testing, for example, status is on. But if I was doing this in production, status would be off. And so I can do this inside of my templates without having to change my code, without having to modify my template, and use this one template and code base in all 3 of these environments. And at the end of the day, this is exactly what we want to encourage with CloudFormation. one template that can be used across any environment that you have, across potentially any region that you have. And so that's a goal that you definitely want to chase after. Now we've got some other capabilities inside of SAM that make it pretty powerful. So one of these is called safe deployments. So inside of Lambda, we have a concept of what's called Alias traffic shifting. It allows you basically to shift traffic towards a Lambda function, essentially the invocations, from one function to another. And so what we can do here with SAM is we can actually automate the deployment process such that we can safely deploy from one version of a function to a new one, ideally without impacting the majority of our customers. So let's talk a little bit more about what we can do here. So there's a parameter you have to specify, or an attribute called auto-publish-alias. And this is going to allow you to define an alias for your Lambda function. And that's where you can point your invocation sources at. And then we have a deployment preference type. And so we see here a couple of predefined deployment preferences. For example, canary 10% 30 minutes. This says send 10% of the traffic to my new version for 30 minutes. If everything goes well, increase it to 100%. We'll see here that if things don't go well, how you can react. We also have linear configurations. So we see linear 10% every 10 minutes. As the name sounds, every 10 minutes, we're going to increase traffic 10%. Again, if things go good, we'll keep increasing it. If at some point things go bad, we can roll that back. That ability to roll back is based upon the fact that we also allow you to do this deploy while watching certain alarms in CloudWatch. So you can specify key alarms inside of CloudWatch that you want to watch for, such that if one of those alarms is triggered, it will halt the deployment and roll it back for you automatically. And so inside of Amazon, automated rollbacks as part of a deploy process is one of the key things we do inside of our CI and CD pipelines to prevent you as customers from ever seeing failures. And so we'll roll traffic out at a very, very small percent, let it run for a while. We've got a number of alarms that we're looking for. If things go good, then we continue on. Again, if they don't, we fall back. We also have the ability to execute triggers before traffic is sent to the new function and then after it. And this can be used for things like put a message into Slack that says deploy is happening. Update your CMDB, update a ticketing system. There's all sorts of different things that you can do as part of that. And so again, this is part of safe deployments inside of SAM. We also have a concept called SAM globals. And so what we see here in this example of a single SAM template is I have 3 different Lambda functions. But up in the global section, what I've done here is defined a number of attributes that apply to all of these functions, such that if I want to add another function to my application, I don't have to specify those attributes all over again. And so everything that exists up here in the globals, again, will roll down to all of these functions. But if I wanted to overwrite them, for example, in a function that's called here getBirds function, I have a timeout specified down there. That timeout will take preference over the globals. But again, what this allows me to do is write even less SAM template code as part of deploying my application. And we see here all that I have is basically the name, the type, a handler, and then the event structure. So again, really, really simplifying and reducing the amount of code that you need to write in building and managing your serverless applications. Another helper that we have is something called SAM policy templates. And so we see here inside of my serverless function that I have a policy. That policy that's defined is called DynamoDB CRUD policy. And then it references a table name, which we see down below is from a simple table. And so what this is actually going to do is expand out to a full policy that's been predefined as part of SAM. And so you could go actually into the SAM repo, and you can find the policy templates.json. And so again, this one line and then a table name reference is actually going to expand out to this full resource policy. And it's in JSON, and so I basically just cut off all of the closing brackets here. But you can see all of the IAM resource capabilities for DynamoDB that this one single line allows us to do. So again, instead of writing all of this JSON or all of this YAML, I write one line, I reference my table, and it's going to expand out to this for me. Again, just making it that much easier. And we've got a whole slew of these policies that exist inside of the templates JSON. And this is another area where we've been getting really great community feedback on how you can make this better and what other things you'd like to see added. So feel free to go in and issue a request, or issue an issue or pull request against the repository for this. So some best practices. Really try to lean on parameters and mapping so that you can have a very dynamic template. Again, the goal that we have is that you have one CloudFormation or SAM template that could be used for your application in any environment that it runs, whether it be locally, in test, in prod, in staging, in dev, in US East 1, in US East 2, in Dublin, in Singapore, wherever you're running, lean on parameters and mappings to make that possible. Lean on globals and also those resource templates or resource policy templates to simplify what you have to write. Very often when you have a serverless application, and let's say you've got 20 Lambda functions that represent an API, they almost always are going to have the same runtime environment, the same timeout policies, the same memory. And so you could put all that up into globals and again, reduce what you have to write inside of your template, just streamline it that much more. We didn't go into imports and exports too much, but you can read up about those in the CloudFormation docs, but it makes it really easy for you to say, have a CloudFormation template that defines, say, relational database, and then be able to pass in, say, as an environment variable based on the environment your application is running in, which database you should connect to. And so imports and exports really help with this ability for you to have a single template that can be used in multiple places. And then lastly, and this is one that I always have to say, there's a joke out there that many people have testing environments, some actually have it different than production. And so think about building out multiple environments, aim for that being kind of the beginning of your process. And so really kind of start with parameters as mappings as being a key way of inputting values and attributes into your CloudFormation templates so that it's just that much easier to do, for example, dev, test, and prod. One of the greatest aspects I think about serverless is that you only pay for what you use. There's no idle. So if you have various environments, again, testing, development, pre-prod that exist, if you're not sending requests to them, they don't cost you anything. Versus if you have that, say, in EC2 or in a container world, you're paying for those environments when they're idle. So again, idle environments in serverless don't cost you or shouldn't cost you anything, and again, makes it much easier to follow the best practices of development. So in terms of structuring serverless applications, this is a big one. This is a little bit deeper for those of you that might be newer to this. We get a lot of times people saying, do I do a single function per repo? Do I do multiple applications inside of a same repo? How do I think about this? Essentially, unless your function handlers, unless various Lambda functions that are part of the same application need to share code, put them into their own Lambda function file or their own jar, for example. And this is going to allow you to potentially, if you ever have to split that application up into, say, multiple services, it makes it much easier versus if you have to pull out code from a single small code base. And this is a great place for you to lean on things like language-specific packages, like NPM packages or pip packages or Maven files or NuGet packages for .NET. Unless your Lambda functions share an event source, completely split them into their own applications. So if you have some Lambda functions that are, for example, taking data off of a Kinesis stream and writing data into DynamoDB, and then you have some functions that are behind an API gateway that pull data out of that DynamoDB table, you actually have two applications there. You have a Kinesis stream consuming application, and you have an API-based application. Even though they share a common data source, split those into two complete repositories, two pipelines, two everything, and then make that DynamoDB resource something that is imported into each stack. And so that's kind of the best practice there. And then lastly, it's really easy to use linting tools and syntax checking tools and SAM validate to validate your CloudFormation templates. You want to do this before you commit so that you're not going into a whole pipeline process, waiting for CloudFormation to fail and all of that. So do linting locally before you commit. I'll make that part of my commands that I run when I'm developing serverless applications. And then do it again in your CI and CD process. Really basic, easy testing of your SAM templates that helps you save time. So we also have this thing called the Serverless Application Repository. It's another great place to learn about serverless and to share applications. Today, you could go in there and find a couple different 100 applications, ranging from things like Alexa skills to Lambda functions that give you all sorts of financial tooling capabilities, like different calculations that you can do in mathematics and equations. And the Serverless Application Repository is actually largely powered by SAM. So in order to commit an application to the repository, you have to have a SAM template. And so this is kind of powering this little ecosystem that we have here. There's a lot of interesting stuff going on. It's only been out for about 3 months now. But we see this being kind of one of the key ways that organizations are starting to share code with each other. For example, a lot of the ISVs that we have, companies like Datadog and Splunk, have functions inside of the application repository that you can use in your account that allow you to better use their services. So check this out, another great way to learn about quality serverless applications and how to build them. Lastly, pretty much everything that I've talked about here today can be found at aws.amazon.com/serverless. This is the homepage for serverless that we have. Kind of in the middle white bar at the top there, you'll see a bunch of different links, things like developer tools and resources, getting started guides, links to the serverless app repository. And so you can start here and find all sorts of things, other talks, webinars, Twitch videos, white papers. We've got all sorts of stuff there, so check this out. Again, my name is Chris Munns. I'm the lead developer advocate for serverless at AWS, based out of New York City. You can find me at munns@amazon.com. Feel free to reach out. Happy to help you out. You can also come and nag me on Twitter at Chris Munns. Always happy for a conversation there. And then I'm going to take questions outside just so we can turn over the room for the next speaker. Thank you so much for coming. Please rate this session, and have a great rest of your day.